So series, I mean, that's the whole key of this topic. How do we actually find the value of the series or the sum of the sequence? Well, clearly I could do it this way. I could simply add them all up. I could get term 1 plus term 2 plus term 3. That would equal the sum to n. Shorthand way of writing that, of course, is using the sigma notation, same as we do in stats. You remember sigma, function x and all that sort of stuff? Capital sigma stands for the additive sum, the general term there, and then we say, well, where are we going from? Now, of course, normally we start at the first term, but you don't have to. You could start at a different term and go to something else. So there's our formula, 2n plus 3, obviously an arithmetic one, because it looks like a linear function. And we're going from 1 to 5. So yes, I could physically work out every single term and add them together and come up with 45. Not the most efficient way of doing it, but yeah, I could do it that way. What about if I'm told that sum to 10 is 29 and the sum to 11 is 37? Could I find the 11th term? And yeah, of course I could. Because clearly the difference between the sum to 10 terms and the sum to 11 terms must be the 11th term. So through the subtraction, we get 8. They've given me a formula then for the sum to n terms. But using that same logic then, I should be able to come up with a general term. Because I could say, well, the general term, term n, must be the difference between the sum to n and the sum of n minus 1. That would leave me with the nth term. So let's substitute in. Expand out, tidy it up. There's my general term, 10n minus 5. Not the most efficient way of doing it. So what's a more efficient way of finding the sum of an arithmetic series? Well, if I did physically write them all out and add them up, I'd go A, well the next one would be A plus D, the next one A plus 2D. And I would keep going until I get to the last term, which I've just called L. Well, the one before that must have been L minus D. And the one before that, L minus 2D, and so on. And in fact, that is so good that I'm going to write it again, but backwards. Doing it that way, we see something quite neat. We've simply got simultaneous equations here, but notice what we've got. If you look at them as columns, if I add them together, I've got A plus L, A plus L. Oh, D minus D goes away. A plus L. 2D minus 2D, goes away. And you can keep doing that. And so we get all of these A plus L's, A plus L's, A plus L's, A plus L's. How many? Well, there must be n of them because we had one of those for each of the terms. So 2 lots of them is n lots of A plus L. Therefore, the sum to n is n on 2 outside of A plus L. And that's great if we know the last term. If we don't know the last term, then instead of L, I can say, well, let's put in the general term. That'll be the last term. Tidying that up, we get n on 2, 2a plus n minus 1d. Now be careful with that one. It's very easy to make a mistake and go a plus n minus 1d because we're so used to using that for general term. But remember, what we're really looking at in there is a plus l. So we've got 2 a's plus the n minus 1d. So now let's do this. We know the first term is 3. We know the sixth term is 96. So what is the sum of those 6 terms? Well, I know the last term. So I can go n on 2, a plus l. Simple substitution. And we get 297. Find the sum of the first 100 even numbers. And let's just pretend for now that I don't know what that 100th even number is. I just can't work that out. So I know that the first term is 2. The difference must be 2 because even numbers go up by 2. And there's 100 of them. So because I don't know what that 100th even number is, I could use the 2a plus n minus 1d formula, substitute in, tidy it up, and there it is, 10,100. The sum of the first 10 numbers is 100. The sum of the first 5 numbers is 25. So let's find the first term, the common difference, and what the general term is as well. All right, sum to 10 is 100. Well, that means that 10 on 2, 2a plus 9d is 100. Tidy that up a bit. Sum to 5 is 25. 5 on 2, 2a plus 4d is 25. Tidy that up a bit. And we've got another set of simultaneous equations now. It should be possible to find a and d. So eliminate the a's. We've got 5d is 10. Difference is 2. Subbing back in, we get that the first term must have been 1 in this number pattern. Subbing into the general term formula, we can now create it. So we get 1 plus n minus 1 times 2 tidies up to be 2n minus 1. Voila. Here's one in sigma notation. So sigma notation, well, let's work it out. The first term is when I sub in 1, so I get negative 3. The last term I'll sub in 10, I get 24. And there is obviously 10 terms. So I'll use the A plus L formula for this one. Sub again, 105. Okay, so 1E and 1F. Oh, I guess what I should say is just be careful with that sigma one, because if that first term is not n equals 1, don't get caught out by that. But also be careful with the number of terms. Say it was going, or let's say instead of 1 to 10, say it was going from 4 to 10. How many terms are there? So don't just go 10 minus 4, 6 is 6 terms. Because remember, it's inclusive. So it would actually be 7 terms. So just be careful with that.